What is that jacket? Does
This
that
is
have a
from.
story?
This is just from Sue. It's from Scotch and Soda. Is that what that is?
Nice. Colorful.
I think, and it's reversible. So I went to one party and I wore it backwards, and then I put it on this way, and that was my fun little party trick.
Got nerdy lady in the house.
Nice on Twitch.
Twitch. Yeah.
Yeah, I want to talk to you. Maybe I can get the beer girl to help. Ella baby，你可以帮爸爸一个忙吗？你去冰箱里面的下面给爸爸拿一个啤酒，可以吗？Yes. She's at the age where she's programmable and helpful, and also evil.
Not fighting back yet.
Not fighting back yet. Not judging. All right, so we've got a beer. I guess we can start with the beer, right? So Winter Mingle from, I guess this is Magic Hat, right? Been doing a lot of stouts because they archive well, and I've got a large archive shipment of beer. So we're doing this cold, nice and cold, because it's Winter Mingle.
Mm-hmm.
It is not beet. It is very watered down, a watered down vanilla-y beer. This is not intentionally offensive, and I could drink two of them, but low threes. It's just having so many good stouts this past month. It's like it shouldn't taste watered down. I don't even know how watered down the word means, but it's not round enough.
What is the brand again?
Magic Hat, also known
Magic
for their
Hat.
number 9, is their most popular beer.
Oh, yeah.
Natural flavor, 5.8% alcohol. Try it all
Hello.
warmed up. Hey,
Hi, Bill. Hi,
how you
Dan.
doing?
Nerdy lady.
Doing okay. Yes, go ahead.
Always coming in something new. So, Hugging Face, right? So, Hugging Face is the GitHub of data science, apparently. Everybody here uses GitHub, right? So, we're familiar with,
Mm-hmm.
compared to
Yeah.
Hugging Face, same thing, but different direction. So, if you just looked at it, you might be like, oh, this is a copy of GitHub. It's got a repo, it's got files, there's commits, but it also has models. But then you can actually use this stuff.
Mm-hmm.
So you can actually run these models. That's nice because setting up machine learning neural networks, or AI if you're using the words, it's a lot. Getting it to run, the production ops of neural network programming is intense. You've got to have the right hardware. None of the hardware works. You have to compile your drivers. You have to be on the right operating system. It's a real pain. And so running this stuff in the cloud really makes sense. The topic today is, here's a new community. You know, it's a great community for data science. And so how do we win? How do we become famous on Hugging Face? And so the answer obviously is to just share. This is the future. We share. We do science by sharing. And we can look at one of the data sets that is the most popular here. And the highest one up here, I think, is a low effort, but it's a quote list of awesome ChatGPT prompts. It's going to pretend it's a Linux terminal.
Prompt engineering kindergarten level.
Yep. So we're going to take this prompt. So this is a technique you might have seen before. Okay. So this can be useful to try things. I've seen a really popular example was emulating a SQL server. And there's other ones. And quickly you find out that this list here is very templated. So you'll find out that these are very similar, these different rows in the box. Okay, so it's going to be your coach. I don't know if this is really specific. I mean, you can ask the normal ChatGPT without needing it to be a coach for you to get these type of answers.
Yeah. I never do the role-playing stuff.
I can't imagine that in the future we will not have this running full time. Looking at everything on your screen, just being in the corner, and then Clippy, just
Oh, yeah.
and having like 3 or 4 of them. This one's watching what you do, and it's suggesting, and maybe this one's watching you through the camera and suggesting, and just having different personas of the same program. I think it'll be valuable. But this
Yeah,
list, as you
it's
get
like
through
your
it,
team.
Yeah, because you have meetings, and we talk about diversity in meetings, and a lot of times diversity is not diversity, but you can, if you're talking to computers, you can program in diversity. You could say, I want 4 diverse opinions on this, and even
Right.
that can be valuable. So after you look at this list for a little bit, you realize that these all things were created as a template. Then when you get to the bottom, you realize actually there's even a template to create these lines in this file. And that is the #1 prompt. That is the #1 data set on Hugging Face. That's got the most likes. I'm going to beat that. No, I'm not going to beat that. But it's just, it's always good to see, like, what do people value? What are things, what are people doing? How do we get into the scene? How do we break in?
Right.
And so I wanted to look at that. I decided I'm going to create a data set first. I've done that. So I actually worked on a project and I'm contributing a data set. So I've got a data set here. So I want to share my first data set that I'm sharing on Hugging Face. And it is 1 million commits. So this is a large variety of Git commits from across GitHub. Version 1, released today, MIT license. Okay, so basically what I did is I went across GitHub randomly and found 1 million different commits from different repos, mostly from different people. Got them all together, shoved them in a SQLite database. It's about ½ a terabyte. I'm slicing it up. It's still uploading. It's very slow to upload. I'm like maxing out my internet. And yeah, thanks to Dan, thanks to some other people using their API keys referenced here under acknowledgements, using these keys to scrape a lot of GitHub data, like nonstop for several weeks. And it was fun. So I got the data, and what can we do with that? Like, why would you need 1 million commits from GitHub? And so that's part of it. So this is storytelling, right? So you've got data, we've got story. Hey, speak of the devil. Thanks for 37.
Yeah.
So we've got all this data here. So we're going to tell people what we've got, and then we're going to kind of talk about how we can use it. Also, there's a best practice here I want to recognize. We have something called model cards. So we've got 1 million commits, and so this represents, let's just assume they're random. It represents code that was put into different places of GitHub over different years, over time, by different people in different languages, different projects for different reasons. It's a big variety of work getting done.
How many commits are there in total?
I think
GitHub?
there's 100 million repos on GitHub. I think that's the quote. And I should be able to guess an average number of commits is, I'm seeing hundreds of, an average is like somewhere near 100 or plus or minus 100. I don't know, logs, it's hard to average a log scale, but let's say 100 is average. And yeah,
But
so
the
let's
median's probably like 2, right?
I know. So that's the problem. The average is blown out. So let's say 100 on top of 100 million repos, we're looking at 10 billion commits.
Sounds like that order of magnitude is reasonable.
GitHub's on the phone, they're laughing. You're off by orders of magnitude.
Yeah. But I guess with this data set, we could explore patterns in that.
So, well, what could you do with 1 million commits? So I got that on the screen right now. If you're looking at commits as code, then if you had a bunch of commits, you could learn how to summarize coding work because commits have commit messages, and then you could do the reverse. So you could take a intent, which would be a commit message, and then you could guess how to perform a task. If you had a lot of code, you could actually learn the syntax of all the programming languages just by looking at the syntax of the diffs. This is something that a large language model would be well suited to do. But this applies for syntax of code, like writing C versus Lisp, but it also applies to syntax of file formats. For example, like a config file. And a computer can pick up on that. This would be well suited for that because a lot of times there happens to be code that goes into GitHub. You could also do some type of reporting or sentry or scoring, trend, review, learn something. Like the goal is not to go do programming stuff, but it's kind of go like extract some insight. Obviously, one type of thing that a lot of people like to do is just how popular are programming languages over time. But other types of things that you could use a model for with this type of data is you could look for trends across time. You can track the influence of things over time. So like this project comes out and maybe it influences the other projects which depend on it. You could look at popularity not just as how much people are using a project, but you could talk about who's talking about a project. Like how many JavaScript programmers are saying, I wish I was doing this in Rust instead. Because that's something too, is a lot of times people program in a language, but they don't like it. So you can actually look at like by seeing how happy people are with the language and identify maybe there's an opportunity. Maybe there's other people are using the language, they don't like it. And but you can see that. Like maybe everybody's using it, but they hate it. And you can look at that sentiment in the commit messages. I've definitely put in commits where it's like, I'm doing this because I'm working around Internet Explorer 11. You will definitely see commits like, I hate Internet Explorer 11, and that's why I have to do this. And they'll just tell you. And that is things that machine learning loves to pick up on, that type of stuff. And something else where you can extract structure from mess is you can actually go find project layouts. So what you do is you go find a type of project, and you're like, okay, go find me a lot of projects that look like this, and what is the most popular format for setting up your project, or how would you lay out the files in your repo? And this kind of helps with a template, so making a template.
I haven't seen anyone do like take a data-driven approach to that.
I've seen one of them is the PHP Skell project. This is actually an inspiration. So this person downloaded a lot of PHP projects that are in Composer, Packagist. And they did an analysis of them, and they wanted to see what is the most popular ways that people are putting the PHP files into their repo. And they came out with some specs. So they turned it into a specification. And they said you must. So if must. So if you have command line executables, they must be in a directory named bin. It's cool. And so this scales. Yeah. So this idea, you could just take this page right here. You're like, this is the research I want to do. Copy, paste this. Here's all the data I have. Copy, do this for every other type of language. So the next topics here are based on model cards. So there's not a thing as a dataset card. Models are really powerful tools. They can take text and answer questions, and they can tell you how to cheat on your homework. They can tell you how to fix your car and tell you how to kill yourself. What? Yeah, they can do anything. So there's also problems. They can do bad things. And so before you put that out on the wild, you better warn people, okay, it's pretty good at helping you fix your car, but it might give you suicidal, tendencies. So watch out for that. These things should be disclosed. So there's a best practice, there's a paper, I think 2018, that explains these are the categories of things you should disclose when you're letting a model out there. So if you're gonna put a model out there that can hurt people, let's just explain how it can hurt people. Notice how they didn't say, don't put the model out there, because you'll never know. I mean, these things are billions of data points, billions of neurons, and you just really don't know what's inside these things. And we're gonna be publishing these things faster than we can validate and test them. It's really hard to test them. There's ways to hack these things. So there is suicidal tendencies in all of the models. All the models, somewhere inside there, is a human that was suicidal, and it came through, whether the way that they drew their artwork or the way they wrote the text on the page, right? So humans are evil. Humans do things. We train robots with things. Therefore, robots have latent evilness inside of them. The best we can do is reason about it and disclose. And that is the best practice. And let other people deal with it. Like, for example, ChatGPT, if you try to ask it things, and one of the major questions that people ask GTP is how to hurt themselves. And so they published about this, and they're like, okay, well, we can't train the model to not answer that question, but we can make a workaround.
They're going into the models and tweaking them.
But then you'll never achieve.
But that's like harder to do.
Yeah, I mean, this is original research, but if you allowed people to draw pictures of dogs, pictures of happy dogs, and some of the humans that drew pictures of happy dogs are evil and deranged people, then somehow in the pictures of happy dogs, there will be evilness. And if the computer's trained on this data, somehow, whatever the artistic constraint is, evilness will get in there. And so it is impossible to train a model to be good. It is impossible to train a model to be good if it's based on human data, because humans are not good. Goodness and evil are human constructs, right? And so there will always be evil humans, and things that are good today become evil in the future. And therefore, the best practice is we just have to think about that. We have to discuss it. thought about this. I could only come out with a couple ideas. There's a baseline goodness assumption. If it's legal and it's on GitHub, then it can be in this data set. I tried to identify skews or population biases like that, and I only found a couple, so I just closed them. There's metrics, so if you've got some numbers you can share. I'm actually still uploading it, so I don't have the exact byte count, but I'll put metrics like that. Data format, obviously you want to explain the format, and I did that. I've got a JSON schema, good stuff. Methodology, you want to explain how you did the data collection. So we used GitHub APIs. Thank you, participants on this call. I filtered to only find open source, free access licenses. These are the ones I picked. If you like, you can filter the data set further. I didn't want to include copyleft licenses because that means maybe the whole thing becomes copyleft, which is unacceptable to Apple and a lot of people. Also, I tried to pick licenses that did not require me to put a copyright notice on the homepage because I didn't have room for 1 million copyright notices.
So I wonder, given these like sampling factors, how does that change the sampling space of this data set?
Yes.
Like for instance, like what percent of repos are covered in that set of licenses and what isn't?
Right. So licenses can be a sampling skew. So more commercial licenses, honestly, are probably not public on GitHub anyway. Copyleft licenses, I guess, are the main thing we're excluding, GPL.
But there might be ways in which this makes it better for some use cases. Like for instance, if somebody is analyzing like real open source projects, but that anyone can use for their own purposes, this is a better data set than the whole population of GitHub repos.
Because they couldn't use it, right?
But also, like the data would represent repos that commits just don't represent like fully open source communities.
Right. The way that I did the randomization is I just picked random words, and then I searched GitHub with those words, and then as the new commits came in, I sucked out random words from those files and then repeat.
So interesting.
It's an ever cycling list of random words. I needed to get results that are give me enough results, but not spill into pages because you can't like get page 2 of the results.
And could that give you like the same commit multiple times?
It's 1 per repo.
Okay. So 1 commit per repo.
Right. So each repo, when I find a new repo, then it gets a commit. If it's an old repo, then it does not get it.
What's the distribution for like the time of the commits in the data set?
That's a good question. I haven't done that yet. But yeah, like per year would be helpful.
Yeah, I'm just thinking for anybody that wants to do like time series analyses that you mentioned.
Yeah. So there's the last question, which is very important. Ethical considerations. So you've got to take all of the biases and other things that could go wrong with this data set or model, and then think about the problems it could have. I only came up with one, and it's real simple. When you use GitHub, the email address of everybody is included in the commits. Everything you do on GitHub, by default, unless you hide it, your email address is attached to that commit. So I'm also publishing 1 million email addresses of people that use GitHub.
Right.
Which is not ideal. Right. So then I thought, okay, well, should I remove the email addresses? Should I actively delete email addresses from commits? And that was my question. I was thinking about this for a while. And I've used GitHub for, I don't know, from the beginning, for quite a while. And I thought, okay, well, have people spammed me on GitHub? Me personally. And actually, no. I've gotten so much great contact out of GitHub. I've gotten job interview requests from Fortune 10 companies, multiple, allegedly, these could be scams, but from .edu email addresses from people that appear to be doing research. So PhD students just looking up open source methodology. Yeah, and plenty of those emails. do I want to spare everybody else these type of, unsolicited outreach? And I'm like, I actually never got any spam from GitHub. I never got anybody like selling me DevOps. So I did my own cost benefit analysis. I was like, I've actually done well with the contacts I got on GitHub. Never took any of the jobs, but they were definitely, positive EV, I guess. So no, I did not filter it. Now, and maybe I'm justifying, I'm mansplaining. And I said, well, if you really wanted to be a spammer, do you want to use this data set with just a million random email addresses? Or would you be better off if you're selling like a DevOps product to go find people that use DevOps? It would be more effective for them. Also, the thing about spam is if you send 1,000 spam, they go through. If you send 1,000,000 spam, you get blocked. I don't think I'm helping spammers. Maybe I'm just comforting myself or excusing myself. But end result is I felt like the risk was acceptable and I did not filter email addresses out. But I did give this explanation.
Yeah.
I wrote it down. Caveats, minor note here, acknowledgement, citation. That's it. So that's my first data set. It's pretty big. I hope it's helpful. I hope we find people that are, going to use this stuff. I hope I can use some of this stuff and just do some of these research questions. So what do you think?
Yeah, well, this is probably the reason there's more models than data sets. Because with models, you can just write one little Python script, and that's a model. But data set, it's as you've just experienced, is a bunch of work. But it's the foundation for anybody that wants to make models.
That's right. And you can fork too. So you can take an existing model, get the model, and then train it on a new data set. And then you can say, well, that's my model now. Because Llama has been used in a lot of places. So they just take Llama, they take a Llama 7 billion parameter model, and then they put stuff in it.
And the LLM leaderboard is like half of it are models that have just like tweaked a couple things to Llama.
Yeah.
Or from some other open model. But yeah, this is great. This is my first time hearing like the story of a data set getting created on Hugging Face from idea to a data set on Hugging Face, which is really cool to hear how it all came together and like the parts of the data card that I don't know, like, did you come up with them or does that seem to be standard across data sets?
So for models,
models, okay.
Yeah. So I'm applying the idea for models. Let me see if I can find it.
I guess model cars.
Model cars for
model. A lot would be about like the UI, right? Like how you get Gradio.
Well, here's the point. There's a paper explaining what you're supposed to do when you release a model. Now everybody does this. This is the paper, and so they've got an example here: smiling detection in images. So they're gonna do smiling. I'm just gonna shoot from the hip. Smiling detection. Okay, problems with black people because black people are hard to photograph with cheap cameras. It might not detect black people smiling as frequently as lighter skinned people. Boom. People from different backgrounds. People smile different ways. So people in certain countries they're gonna look like they're smiling, where they might have a more subtle smile. So the computer might not pick up on that because it's comparing people across different cultures. Those are things you absolutely need to say. If you've got a model that detects people smiling, but it doesn't pick up as well for people with dark skin, you need to say that. Like that is a huge thing with image detection with faces. Luckily, newer phones in the past 5 years are getting much better for different skin tones, but it was very difficult to make machine learning models for people with all skin colors. This is a known problem with image detection. But luckily, we're focusing on it. So if you just took an old image data set and then you did all this stuff on it, we're like, okay, well, that's a problem. So they're even saying it right here, like factor for gender, age, race, skin type, camera type, and lens type. If you're going to release a data set about smiling, you better say, is this using a Samsung camera in the past 2 years, or is it using an old camera that we know has problem with different skin tones? That's something you need to say every time you release a model. And so they're giving an example. This is a great example. Training data. And then they can go a little deeper because they can actually have like a validation suite. So they can do testing and they can say, well, here's what our model said and here's the stratification. Our model does well here, but our model doesn't do well here. I don't have that for a data set. I don't. The data is the data. The data is the input. So data is truth. So I can't really do
Yeah.
that.
But you talked about the sampling methodology, which
Yes.
is kind of the data set version of evaluation.
So caveats does not capture race or skin type, which has been reported as a source of disproportionate errors. There's a citation that's not. It's not a real citation, but they're guessing you should cite that, and that's the number one caveat. So this applies to models. This is a paper. This is a well-known paper. Everybody's read this about model cards, and so I think it's best practice to apply this technique to dataset cards. I'm not going to write a spec for dataset cards. I'm not going to write a paper about that, but I think it's close enough that we can just, follow
Yeah.
your way through it.